Honda's mission is to develop fine cars that are fun to drive, in accordance with our basic principle of respect for the individual. In continuing to refine the fundamentals of automobile performance, we are pursuing a sense of unity of driver and vehicle, with handling performance that directly and faithfully expresses the driver's intent. Honda's independent research starting in the 1980s led to the establishment in 1992 of the beta method of vehicle handling performance. Featuring comprehensive evaluation and analysis of vehicle handling under all conditions, from normal driving right up to the leading edge of sporty performance, this method has become a mainstay of our quest for improved vehicle maneuverability. Based on research using the beta method, we developed a lateral torque distribution system called the direct yaw control system. In 1996, Honda introduced ATTS, which generates cornering force in front-wheel drive vehicles by varying the torque distribution between left and right. Now Honda has applied the technology for generating cornering force with torque to all-wheel drive vehicles. Introducing the SH-AWD system, the world's first super handling all-wheel drive system, a major leap forward in vehicle maneuverability on all road surfaces. The SH-AWD system flexibly regulates torque distribution to all four wheels to achieve a major improvement in vehicle maneuverability. All-wheel drive systems distribute torque to all four wheels for enhanced driving performance. Some conventional all-wheel drive systems use a fixed ratio, some a variable ratio of torque distribution. In this system, a center differential varies torque distribution to the front and rear wheels. And in this system, a rear differential varies torque distribution to the left and right rear wheels. In the new SH-AWD, the twin clutches of the rear differential achieve simultaneous control over front-rear torque distribution and lateral torque distribution to the rear wheels, a world's first. SH-AWD varies front-rear torque distribution within a range from 70 to 30 and 30 to 70. Lateral torque distribution to the rear wheels is controlled within a range from 0 to 100 and 100 to 0. Simultaneous and continuous control over both factors ensures that the optimum amount of torque is always distributed to each of the four wheels. While maximum torque is distributed to the front wheels, torque to the rear wheels can either be distributed evenly or adjusted laterally to deliver more torque to one wheel than the other. On the other hand, torque to the front wheels can be minimized, while complete control over the ample torque sent to the rear wheels is maintained. Now let's take a closer look at the SH-AWD's features and benefits. Accelerating through a curve can lead to understeer, causing the vehicle to drift wide of the driver's intended line. In this situation, SH-AWD distributes more torque than usual to the rear wheels. Further, extra torque is distributed to the rear wheel on the outside of the turn. Directing more torque to the outside wheel generates inward yaw moment, which helps prevent understeer. SH-AWD also flexibly controls the effects of engine braking, which is produced by engine resistance when the driver eases off on the throttle. Easing off on the throttle when turning can lead to oversteer, causing the vehicle to veer inside the intended line. Under these conditions, SH-AWD distributes much of the engine braking to the outside rear wheel, preventing oversteer for more stable cornering. Let's see how this works in an actual vehicle. Even when the throttle is opened up during high-speed turning, no understeer occurs, and the vehicle traces the ideal line through the curve without steering correction. The driver can turn with less hesitation, manipulating the throttle more confidently. SH-AWD delivers these same benefits on snow, wet roads, and other challenging surfaces. Here, the vehicle is accelerating in a curve. Extra torque is delivered to the outside rear wheel to suppress understeer. During straight line driving as well, SH-AWD controls torque distribution to the wheels in accordance with tire load for maximum driving efficiency. Now let's have a look at the SH-AWD mechanism. SH-AWD employs the world's first rear differential to include direct electromagnetic clutches, step-up mechanisms, and an acceleration device that increases the speed of the rear wheels. The SH-AWD's system's ECU calculates the optimum torque distribution based on input from the engine ECU, along with wheel speed, steering angle, lateral G, and other sensors, and conveys the results to the rear differential. Torque control is implemented by the direct electromagnetic clutches. The electromagnetic clutch uses the magnetic force generated by the electromagnet to attract the outer magnetic body. The magnetic body presses on the multiplate clutch, increasing its gripping power. The amount of torque distributed to the rear wheels increases with the clutch's gripping power, and the amount of torque distributed to the front wheels decreases proportionately. Torque distribution between the front and rear wheels is controlled by varying the amount of magnetic force. In addition, independent control of the left and right electromagnetic clutches is used to freely control the torque distribution between the rear wheels. SH-AWD uses this configuration to achieve highly precise front-rear torque distribution and independent control over lateral torque distribution to the rear wheels. The electromagnet features surge control to detect and correct the gap between it and the magnetic body, ensuring continuous, high-precision clutch control. The planetary gear step-up mechanism supplements the considerable torque handling capability of this compact, lightweight package. The acceleration device increases the speed of the rear wheels, so the torque distributed to them is used to maximum effect. During straight-line driving, the acceleration device spins in synchronization with the propeller shaft, such that the front and rear wheels turn at the same speed. When the vehicle enters a curve, the rear wheels follow a track outside that of the front wheels. Rotating at the same speed as the front wheels, the rear wheels could not fully utilize the distributed torque. The acceleration device causes the planetary carrier to adhere to the case, releasing the device from its synchronization with the propeller shaft. The acceleration planetary gear increases the rotation speed of the rear wheels. This ensures that the torque distributed to the rear wheels is efficiently transmitted to the road for improved cornering performance. The SH-AWD system is designed to faithfully realize the driver's intent. driver input is assessed by measuring the operation of the throttle, steering wheel, and brake. Torque is assessed by the engine transmission ECU. Driving conditions are assessed by the lateral G sensor, yaw rate sensor, and wheel speed sensors. Based on this information, torque is freely distributed to all four wheels for a major improvement in driving performance. Operation is based mainly on feed-forward control, an active system that detects driver input to activate control functions, anticipating and preparing for vehicle behavior. Thanks also to SH-AWD's feedback, the driver's intent is faithfully, precisely executed. A direct feel. The driver's intent is realized. Crisp handling. The vehicle traces exactly the desired line. A sense of unity. Car and driver function as one. The SH-AWD system flexibly controls torque distribution to all four wheels in response to driver input and driving conditions. It represents a major leap forward in vehicle maneuverability and a new level of driving pleasure.